remember where we started last week. We were talking about taking this grand tour, right, from the coast of the Atlantic Ocean west all the way into Arkansas. We started at Cape Hatteras on the Atlantic, and then what is the term for this region right here that we said formed in the last 65 million years? Coastal plains. Good. And then we climb this line here, which is where what happens? What is that line called? The fall line. Perfect. Yeah. And then we're in this sort of undulating, sort of gently hilly, but it's almost like a plain with low hills. What's that region called? The Piedmont. Perfectly. Perfect. And then we hit this eastern boundary of which province there, and that is the Blue Ridge, right? So the Blue Ridge Piedmont boundary is what you would see there on the east side. And as I mentioned, a lot of the early settlers used to see that wall of mountains in the distance, dramatically rising. Imagine that on a summer's day in 1680, right? You're looking out across the Piedmont, and you see these mountains in the distance that at that time, no Europeans who were the ones traveling west across this region had ever been into those mountains. But there were lots of Native Americans who had lived in that region for 10,000 or more years. So it was very common to them. And a lot of the Native American tribes, of course, each of them have their own name for those mountain ranges. And so a lot of that information still persists with the tribes. Some of that, unfortunately, because some of those tribes have been driven to extinction, that original name of some of those tribes has been lost with them, unfortunately. But as these settlers were pushing west, then they saw that range of mountains in the distance, and they had a blue hue, and therefore they called them the Blue Ridge Mountains. That's the name that we often refer to them as today. They are not one single mountain range. They actually are composed of many different ranges. So, for example, a lot of people in Tennessee don't actually call them the Blue Ridge. Over on the Tennessee side, we have several different names for them. Anybody know some of those names? There's the Great Smoky Mountains, right? But a North Carolinian around, say, Asheville over here, they'll be quick to tell you that those are not the Great Smoky Mountains. If you're over here, just northeast of Asheville, right in here, those are not the Great Smokies, even though they're 40 miles away. Yeah.
What is the geological definition of a mountain? Like, I would see a bunch of mountains roughly next to each other, and I know that.
Well, yeah, there is a larger mountain uplift region. It's kind of like the Himalayas, right? There's this giant chain of mountains, but then there are these individual lines or ranges of mountains separated by valleys from another range of mountains. And that's what we're talking about here. And we'll get into a lot of that. So some various terms are Unaco Mountains, which is a Native American term. Some people in Tennessee refer to that entire range of mountains from northeast Tennessee all the way to Georgia that you would see east of Chattanooga and east of Knoxville as the Unaco Mountains. And so that would be from here all the way down to there. If you're in North Carolina, you have the Black Mountains, the Balsam Mountains, you've got the Cowees and the Nantahala Mountains. So lots of different ranges. But collectively, and for our purpose, we're going to call the entire thing the Blue Ridge, okay? Now, the Blue Ridge actually starts in southern Pennsylvania, all the way up here with this very narrow ecoregion here. Comes across Maryland, just west of Washington, D.C., comes down through Shenandoah National Park here, down through Virginia, where it's very narrow. And then it begins to widen and becomes at its widest in North Carolina before terminating just north of Atlanta down in Georgia. Some people additionally have recognized the Blue Ridge to go on into Alabama right here, almost down to Birmingham, in which case that's called the Talladega Mountains. You've probably heard of Talladega, where they have NASCAR races, right? The Talladega Mountains are an area there that's uplifted. Some people recognize that as Blue Ridge, that little extension there, but other people recognize that as a sort of a range of mountains. It's part of the innermost Piedmont region. All right, now within the Blue Ridge, we're going to be looking at several, that's the larger, what we call level 3 ecoregion. What we're going to be doing now is breaking that down into numerous level 4 ecoregions. The level 4, if you recall from last lecture, is really the level at which fine scale conservation happens. Okay, for example, if we're interested in mountain bog habitats where endangered bog turtles are found, well, we might want to focus in on ecoregion 66F, the Limestone Valleys and Coves ecoregion, because that's where a fair amount of the bog habitat remains for this for the endangered bog turtle. So if you're working on that, let's say you're the Nature Conservancy, you might be interested in all these, see these little pale areas right up here? Those are separate valleys that are surrounded by the mountains. Some of those valleys have very rare bog habitats in their bottom, and I'll show you some pictures of that. But let's say you're another organization like the Southern Highlands Reserve near Asheville, North Carolina. Their sole concern is preserving habitat for the endangered Carolina northern flying squirrel, a very rare mammal that's beginning to disappear, that is tied specifically to the tops of mountain ranges and high elevation spruce fir forests. And that's part of what we call the high mountains ecoregion, 66I. So that's just the highest tops of some of these peaks right up in here. That's the entire worldwide distribution of that endangered squirrel. So you probably want to, if you're the Southern Highlands Reserve, you want to know where those different chunks of high elevation forest are. They're fragmented on different mountaintops so that you can work with groups like the U.S. Forest Service or the National Park Service or the Nature Conservancy to make sure that you are protecting and restoring those species and those habitats. So the level 4 ecoregion is really an ideal level with which to work. But let's say you need to work across state lines or a bigger area. One of the projects, for example, that our organization, the Southeastern Grasslands Institute, is currently doing is we're focused on another region right over here, this one that you call 68A, the Cumberland Plateau, as we'll get to a little bit later in class today. And that covers about 10 million acres across 4 states. And what we're doing is conducting a baseline status survey to say, where were all the grassland habitats originally? Where are they today? What kinds are left? And which biodiversity depends on those grassy ecosystems? Where are the places that we want to restore more of these ecosystems? Where are the big units where we can eventually bring back elk or maybe Florida panthers could migrate to and utilize those as parts of their future ranges? So looking across big regions like that requires us to step back from the level 4 up back to the level 3. So we might want to look at the entire Blue Ridge, for example, as an important corridor. Or you might want to look at the entire Cumberland Plateau as a corridor. But usually if you get much bigger than that, back to the level 2 or level 1, we don't really operate at that scale too much for regional conservation efforts. Okay, so the Blue Ridge, if we were to do a cross section, what's one of the things you immediately notice about the geology of this region? So that's this portion down here in the cross section view. What do you notice? Yeah, very prominently uplifted, right? Okay, what else? Compare this here to here. On the right side of the map to the left side of the map, what do you notice? These are older rocks here. Absolutely. These are Precambrian age. So these are certainly older than, say, 550 million years old, back in the Precambrian era. In many cases, they're over 800 million to 1 billion years old. Okay, so older rocks, that's one. What else? A lot more rock layers. Yeah. very complex. That's certainly true. Okay. And one more attribute of these two areas. James, what do you notice? Comparing this region here to here, what's a key feature that stands out? Anything? I'll throw you an example here of what I'm thinking. So notice how on the left, you can pretty plainly see those layers, right? They're almost in a sort of a flat horizontal arrangement. You see that they've been uplifted a little bit, pushed up by some force, right? And then as they've been pushed up, that has triggered an uplift of a mountain range here. And it's also triggered river systems cutting down. So anytime you raise something up, there's a force of gravity against it to cut it back down. And so with that uplift, you're seeing down cutting by rivers forming canyons, okay? But the key here is more or less level strata. That's a key word, strata, S-T-R-A-T-A. Strata are the various layers of rock, okay? Singular is stratum, okay? Now compare that over here and notice that the strata are highly deformed, very much folded. They kind of zigzag up and down, and in some cases they fold upwards like that. On here, notice this one. They go up and then down. So highly deformed, and that's a really signature characteristic of mountainous regions, is that you have highly deformed rocks. Well, what's creating that deformation? Tectonic collision, right? In this case, you have the collision of the African tectonic plate and also of Europe colliding with the North American tectonic plate. So those huge pieces of continental crust are buckling into one another. They're ramming into one another slowly in geologic time, and then they're beginning to uplift and buckle, and parts of that crust are folding, not only through that mechanical pressure, but also heat, right? Keep in mind, there's a lot of heat involved in this. So what is that heat doing to the rocks? Making them squishy and pliable. And if, for example, if you're sandstone and you got quartz grains, which are the actual pieces of sand, and then let's say that you've got pieces of another mineral that forms the matrix around those quartz grains, right? Then what it might do is that heat and pressure actually melts these smaller mineral grains to where they melt and expand, and it distorts the original sort of structure of those. So you go from a sedimentary rock, which is not at all affected by heat and pressure, which is not metamorphosed, right? So we say that it's a sedimentary rock. But when you apply heat and pressure through mountain building, then you have a metamorphic rock. So what does sandstone become when it's metamorphosed? There's two names I'll accept here. It can become meta sandstone. How about that? You just put the prefix meta in front of it. Or it can become quartzite. That's another word we would use for that. If you have shale, it becomes metamorphosed. Shale becomes slate with more intense metamorphosis. It becomes phyllite and schist and eventually gneiss. So it depends on the degree of metamorphosis. So anyway, a lot of deformation is happening here. Now, the Blue Ridge, one last thing I want you to notice about this particular diagram are these heavy black lines right here. Okay? What are those? What are those heavy black lines? And in particular, I'm not talking about the, for those of you on the screen, look at my cursor. I'm talking about these lines that are kind of right here. that are sort of in underneath this mountain range, not these larger horizontal black lines over to the left. Those are called fault zones or fault lines. And in this case, there's a process known as thrust faulting, THRUST. And the basic premise here is this, that you have a body of land like this that's being pushed up and over another body of land, right? The line, the contact zone, where those two are meeting and where one's being pushed up over another represents that thrust fault where one piece of land is being thrust on top of the other, okay? That's a really important thing. You can actually physically see that line. If you go to the Smoky Mountains, and I'll show you a picture of the exact line, you can see that boundary. So on the west side of the Great Smoky Mountains, for example, the west side of the Blue Ridge, that exact line, which is like, you know, the width of my body, is the boundary between the Blue Ridge and the next region to the left called the Valley and Ridge, or the Ridge and Valley province. And we'll come back to that in a minute. Yeah. Go ahead, sure.
Those three parallel thrust fault lines, are they representing one thrust fault event where it buckles on itself and makes multiple lines, or is it three separate thrust fault events?
Exactly. Each one of these is an independent fault line. You remember like day one of lecture, I showed you that part of Western Kentucky with all those lines, right? Each one of those is a fault line. Well, similarly, if you were to look at East Tennessee, you'd see a whole bunch of individual lines. Now, some of them, probably most of them, originated as part of the same general process. And that process was Africa colliding with North America. And that's what we're gonna talk about over the next week and a half, is that whole process. You may not be able to visualize that now, but I promise you will be able to visualize it very soon. So yeah, each one of these is a thrust fault. And some of them have names like the Great Smoky Mountain Thrust Fault. Okay, here's another simple model that shows not only just the Blue Ridge, but some of the surrounding areas of what's more generally known as the Southern Appalachian region. And what I want to show you here is an elevation profile. And I want you particularly to sort of get an idea for how high these mountains are. The tallest is Mount Mitchell, North Carolina, just northeast of Asheville, right in this region right here at 6,684 feet. And then, of course, the valleys that are just to the west of the mountains here would be down underneath, right at just a bit below 1,000 feet. I'm not sure what that stands for because that doesn't seem quite right. Oh, that's probably up here. But a lot of these valley bottoms are about 1,000 feet in elevation. So in total, you know, you can go from roughly 1,000 feet up to over 6,000 feet. There's about a mile of relief, basically, from the bottom of the mountains to the top. Those that are in white are just showing the highest mountain ranges. And then this sort of gives you an idea of what I was saying earlier. These are the Great Smokies, right? These are the Balsam Mountains. These are the Cowees and the Nantahala, the Unicors, the Black Mountains, the Roan Highlands, the Grayson Highlands. You do not need to know all those, but I want you at least to know that they do have their own sort of colloquial or common names applied to these different ranges.
And all of them each have an individual endemic salamander.
Yeah, great point. Each one has an endemic salamander. In some cases, they have many endemic salamanders, like in the case of the Great Smokies, right? This is the salamander capital of the world. More species there than anywhere, including many species that are still being described. Also, recent research has shown that many of these individual mountain ranges have totally distinct assemblages of spiders that have been evolving in isolation for probably 5 to 10 million years. They've been separated because they're isolated now in different mountain ranges. And millipedes, yeah. In some cases, some plants as well. There's some of these mountain ranges that have totally unique plants, like up here in the northern part are several plants that are only found in what's called the Roan Highlands.
Hey, Dwayne.
What's up? Hey, whoa, what's going on?
Sorry, man. If you use your cursor to show all the little areas you keep talking about, will that show on the screen in the class? Because we can't see where you're pointing.
How about you just buzz off and I won't show you anything?
Thanks.
Of course, buddy. Of course. Right. Thank you for that reminder. Theo happens to be my best friend as well, so I can joke around with him like that. So the Rhone Highlands are right up here, and as I was saying, here's the Great Smokies. These would be the Cowie Mountains right in here, the Plot Balsams and the Balsam Mountains, and then the Black Mountain Range over here. So yeah, each one of those uplifted systems are quite distinct. And then what else I want you to know, guys, is that uplift is highly correlated with things like rainfall. So the tops of those mountains, does anyone know how much rainfall we get here on average in Clarksville on a yearly basis? You had to guess in inches per year. Brandon, you got any idea?
Few inches. I don't think it's a whole lot.
I hope it's more than a few.
Well,
If you're
I've seen measurements over the summer and I think
Okay.
the most we got in the night over last summer was 41 millimeters. Now, that
okay, somebody throw me out some numbers. Laura, you were going to say something. What do you got?
82?
Hmm.
Or
Too
52?
high, too high, Laura Lou.
Okay, 52. I'll go with 52.
52 is great. 52 is great. Somewhere between 50 and 55 inches of rain is average for right here, okay? But in these mountains here of southwest North Carolina, we're looking at right here where Georgia and South Carolina and North Carolina come together. That area is basically a temperate rainforest. The rainfall there commonly exceeds 90 inches of rain, sometimes 100 inches of rain a year. So that's comparable to the islands of Puget Sound in Washington State, or coastal Oregon, up through the southeastern panhandle of Alaska, Vancouver Island, British Columbia. That's temperate rainforest down there, which is really unique, and a lot of the biodiversity then reflects the need for those high levels of rainfall. There are even tropical ferns that are stranded in those mountains with nearest populations in the Dominican Republic. So really cool stuff going on here. Theo, I hope you know, obviously I was joking with you, so please ask away and I'll try to be better about pointing out stuff on the screen.
Thanks.
Theo, I'm sorry, buddy. I didn't mean to give you a hard time. You know, I got to liven it up over here. Got to have fun, you know? All right. We've been in a meeting all day. I don't think Theo liked that, right? All right. So let's start with the first ecoregion. Let's go through them. High Mountains ecoregion. This is basically the region, the text portion here, you guys can be sure and read that, study that a little bit. I'll give you the highlights as we go through. So we're talking about pretty much anything that's above 4,500 feet elevation in these dark green zones here. That's ecoregion 66I. And if you were to look at sort of this photograph of that area, we're talking about the darkest tops of these mountains, like right here, okay? If you get down to the middle of those mountain slopes, around 3,000 or 3,500 feet elevation, you're not in the High Mountains ecoregion, you're in another region. So really, this is only the tops of these mountains. A comparable analogy here would be like if you're around Phoenix, Arizona, or Tucson, Arizona, you're in a desert environment. We have scattered, isolated mountains that rise up. And Jared, tell us what that region is called. Sky Islands, right? So the idea is that these are basically isolated mountaintops that are not physically connected, and therefore the species that live on these islands are now cut off from one another. Imagine the evolution of biodiversity that is helping to foster. This is kind of what a lot of the mountaintops looks like. It's dominated by two trees, red spruce and Fraser fir. If you ever go and get a live Christmas tree for your house each year, Fraser fir is one of the most common Christmas trees that you can go buy at, you know, Kroger or a Christmas tree farm or something like that. Sadly, though, this mountaintop forest has been decimated by an insect, which has ravaged a lot of these trees. That's why a lot of them look dead, or you can see those trunks there. So many of these standing trees in the background were destroyed back in the 1980s and 90s by an insect that killed the Fraser firs. Before that collapse of the forest, these were very lush forests. This looks like a temperate rainforest, right? Extremely mossy, In fact, there's an endangered and endemic spider in this ecosystem called the spruce fir moss spider, which lives on these rocky boulders and on the trunks of these trees, only found on the tops of these mountains. It's a trapdoor relative. Great. Very lush, extremely diverse in bryophytes. These are mosses and liverworts. This is the habitat for the Carolina northern flying squirrel. Red squirrels would be in this habitat as well. Some really cool, there's I think a rare northern shrew that is found in these ecosystems also. Several birds that are found in these habitats like Blackburnian warblers and maybe a few others that I'm not recalling. Here's the second highest point in the Blue Ridge is called Klingman's Dome, and this is found in Great Smoky Mountains National Park. Corley, if you can hear me, and if you can unmute yourself, you don't have to take yourself off video, but can you remind me the Cherokee? I think you told me once the Cherokee name for Klingman's Dome.
Yeah, actually, there's a movement right now for it to get changed.
Do you remember what the name is?
I'm looking. I've got it in my phone.
Well, if you can call it out, great. But I would love to share that with the class. So, you know, a lot of
So
our
it's Kuahi, and it's the Cherokee word for mulberry place, and it's also like pretty deeply embedded in our legends as well.
Excellent. Thank you very much, Corley. I appreciate that. So with Klingman's Dome, you know, it's a second highest peak, 6,643 feet. It's high. It's the Tennessee's highest point. There's a elevation platform up there that you can see. But notice how you know, especially in the winter times, it's often shrouded in snow and ice. Some of these high mountains get in excess of 80 inches of snow per year. If you think about the snow event we just had and how rare is it for us to get even 6 inches or 10 inches, we do have places in our state that receives over 80 inches or over 70 inches of snow per year. It's pretty cool. Some of these mountaintops also have very rocky features. So they can have cliffs and rocky summits, as they're called, or outcrops. These are extremely important habitats. They are important for things like common ravens, the larger cousin to the blackbird or to the crow. They are important historically, especially for golden eagles, peregrine falcons. There's a number of other highly endemic plants that are found only on these rock outcrop cliff tops. And so while these are small habitats, they're exceedingly important from a biodiversity perspective. In fact, some of the cousins to these plants occur in places like Alaska and Greenland and Newfoundland and Norway. So there's some really dramatic connections here to the Arctic habitats of North America. And yeah, Jared?
Should be noted, like birds don't occur outside like the tundra zone or the taiga zone, so like the northern forest. So those Fraser firs are a special Blue Ridge species that's only found in the Blue Ridge, but all their relatives are found.
With the exception of the firs that get into Guatemala. You familiar with those?
Okay, yes, there are some of the Rockies. I'm not on the east side.
Yeah, but still, it's a southern species that has northern relatives, right?
And it's up on the tops of mountains.
The very top, yeah, double the height of these, absolutely. Yeah. And then some of these mountaintops, when you get above the spruce fir zone, in some cases, you get into actually a grassland. And so this is Roan Mountain, right on the Tennessee-North Carolina border. The Appalachian Trail goes right down through the middle of the scene. And these are grasslands that have been open for 20, 30,000 years or more. These are old growth grasslands. And likewise, these ecosystems also support endemic species. One of our former biologists here at Austin Peay, Dr. Jason Mullaney, who was here as a mammologist, now he's in New Mexico State. He was studying the mice up here. And one of the things that he was sort of suspicious of was that the mice in this grass bald community, it's called a BALD, a grass bald. The mice out in these grasslands were different, he suspected, from the deer mice populations that lived in the adjacent forest. I don't know if Dr. Mulaney is still investigating this or not, but he was sort of on the beginnings of suspecting that this was a new undescribed mouse species that was in these grasslands. That all remains to be determined. I hope he's working on it, and if not, I hope someone will work on that, because it'd be kind of cool to see that. You can see these grasslands, how they kind of string out along the ridges of these mountains in some cases, just really beautiful. And sadly, they have been replaced over the last 150 years, especially the lower portions, by forest. And under climate change, they are projected to be lost eventually entirely due to forest encroachment. These are relics of former alpine tundra, by the way, from 18,000 years ago. Okay, that's the high mountains ecoregion. I'm gonna pick it up a little bit because we're gonna get into all these ecosystems in detail in the second half of the semester. So what I'm gonna do is I'm gonna just resist the urge to talk about everything and hit the highlights a little bit. Okay. So the second ecoregion is called the Southern Crystalline Mountains. Southern Crystalline Mountains ecoregion. You'll see this various ways. Southern crystalline ridges and mountains is fine too. It's also called the Southern Igneous Ridges and Mountains. Igneous in this case referring to ultimately rocks of volcanic origin. This region is formed by rocks like granite and gneiss, schist, and various types of other metamorphosed volcanic rocks, which are called metavolcanics. These are some of the highest points that we just talked about that are in that high mountains region technically are, crystalline rocks, igneous rocks. But when we talk about the southern igneous mountains, we're really talking about the lower part below the high mountain zone. Okay. Now, look at this map here, and I want you to notice that the dark green zone, 66D, which kind of forms the sort of the eastern side of the Blue Ridge, versus 66G, which forms the western side. That's very, very important. And I'll point that out to my folks here on the map. We're looking at this 66D kind of right here on the eastern side versus 66G on the west. 66D is this region we're talking about, the igneous or crystalline mountains ecoregion, and it forms kind of the eastern flank of the Blue Ridge.
Is there a built-in elevation scale with the lettering ecoregions? Like I know high mountains is up at the top, but 66J, for example, is that between I and D?
Oh yeah, don't even worry about that. The ordering there is just how
I'm trying to pick the top box.
Oh, I see. Yeah, I see what you're saying. Pretty much you'd have to go back to that profile map earlier to see it. And it's not going to be immediately clear because honestly, it's all over the board. You can have 4,000 foot high peaks like here in river valleys. This does not really correspond to topography.
Do the order of the letters give us any useful information? Or?
Not really. No. So what I would say here is, we started with high mountains. We're going to knock that one out first. Next, we're going to talk about these two big chunks, the east and west divisions. Okay. Then we'll come back in and piece together some of those other smaller ecoregions again. That's a good question. So, all right, we're in the Southern Crystalline Mountains or Igneous Mountains ecoregion. And this is only a little bit in Tennessee. It's really especially over in North Carolina and South Carolina, a little bit of northern Georgia. I'm going to give you a visual tour of a lot of these places. Partly why I'm doing this is I want you to visit these places. I want you to experience it. I mean, Jared, you probably spend 15,000 miles a year traveling and looking at all these sites. That's an underestimate, isn't it? Yeah.
It's close to 20.
I mean, just your drive alone from Washington State to here was
Let's pick up a card.
right. Okay. So, all right, here's one site, Linville Gorge, North Carolina. And these are a group of mountains here, absolutely gorgeous. Lots of meta-igneous rock formations. Places like Whitesides Mountain. I often take some of my classes over to here and we go to the top of Whitesides. To me, it's the closest thing in the eastern United States to Yosemite National Park over in California with El Capitan and some of those giant cliff faces. That particular bedrock there is made of gneiss, Gneiss. The highest waterfall in the eastern United States is Whitewater Falls down near the South Carolina border. Drops over 500 feet across multiple falls, and just a beautiful, beautiful river. We mentioned those serpentine barrens on the very introduction to this class, and this is also in this region, a real rare type. We talked about serpentine. Okay, and I want you to look at this, and the serpentine here, which is represented by this purple color, and there's several rocks that make that up, like, and you don't have to know these especially, but dunite, serpentinite, soapstone. By the way, soapstone is a really highly sought after soft rock that's carvable. Almost, you can not mold it, but you can carve it. And Native Americans would carve soapstone into pipes, you know, smoking pipes and various types of ornaments and effigies. And so once they knew where there were formations of soapstone, like in Georgia, for example, those became quarry sites for Native Americans. They would go back there and mine those, and they knew then they could get a good amount of that rock and make all kinds of useful things, which they could then trade with other tribes who did not have soapstone in their respective home regions. For example, we have no soapstone in Middle Tennessee or Missouri or Arkansas, and that's because we don't have the right geology. Soapstone is a ultramafic rock, which is only found in here in the Blue Ridge Mountains. But look at how rare it is. Just the areas in darkest purple, right? A couple of sites right in there. There's a ring of here, and then right there. Those are the areas where you would find this right here. There's the Buck Creek Serpentine Barrens right down there. There's a ring of purple and the scattering of sites up through here. Those are your ultramafic rock outcrop communities. Remember, we said those are toxic soils, high levels of aluminum and magnesium and manganese, chromium, and those things. But look at all the grades here. That really represents the area of the southern igneous mountains ecoregion or crystalline mountains ecoregion. Here's some common geologies of this area. Granites, the gneiss. Gneiss is this rock that's kind of banded with black and sort of lighter colors here. It almost looks like it's been streaked, and it almost looks like it's layered. Schist is also very common in this region. Now, a lot of this area that is the southern igneous mountains ecoregion, if you were to fly over it in an airplane or look off from this overlook, I want you to notice, tell me what two major color patterns you see here, okay? Just call out two really, really prominent colors, not with the sky, but with the landscape. What do you see? Orange, what else? What's up? Green, okay? Those are good. Orange and green, or yellow and green, you could say, but probably orange and green. So the yellowish orange colors and the reds tend to be the broadleaf trees, your maple trees and tulip poplar trees and those kind of things. But at this late season, probably sometime in October, who knows what the green most likely is? Anybody on the computer?
Evergreens,
Evergreens. Give me some examples there, Laura Lou.
cedars or firs.
Cedars, firs, okay.
Spruce.
Spruce, okay. Cedars like limestone, so not in this environment, right? This is
Okay.
metavolcanic rock. Spruce
Oh.
and fir really only like the high mountains ecoregion.
Okay,
So what's the
Yellow.
common evergreen down here?
shortleaf pine.
Pines. Several different species of pine. That's right. And there's one thing about pines that I'd like for you to point out to me, if you can. And what would that be? Pines like to grow in what type of acid and sandy soils? Exactly. So the granites here and the gneisses and the schist naturally weather into a rock type that is acidic and a soil type that is acidic and sandy. Pines do very well in this environment, okay? You can easily see that from a long distance. And if there's a lot of pine there, and especially if it's dry and acid and sandy, you can reasonably be confident that this landscape also needs a lot of something else. What is that? It is very adapted to fire. Okay, a fire adapted landscape. Okay, now we want to switch gears. We're going to go to a small ecoregion this time called the Amphibolite Mountains ecoregion. The Amphibolite Mountains ecoregion is an area that is, I knew nothing about this just, probably prior to a decade ago. This is the area here is 66K. It's this dark, sort of prominent green zone right there. If you've ever been to Appalachian State University, Boone, North Carolina, Boone, North Carolina sits right in the heart of that Amphibolite Mountains ecoregion. I happen to think this is the prettiest area in all of the Blue Ridge Mountains. So I'm looking at this right here, guys, 66K for those of you on the map. Now, if you look at this a little bit more finely, I like to use these Google Earth aerial images to kind of convey certain points at times. And you can actually see this area of uplifted mountains, right? It's its own kind of distinct province. Notice here that it actually comes slightly into Tennessee. Remember we talked about that one day? And this, the state line comes in, it's almost like they made a mistake. That's exactly what happened. They made a mistake in doing this. They got off track. They should have kept going straight across. But they made a mistake and came over here, climbed up to the top of Snake Mountain, followed the backbone of Snake Mountain about a few miles, and said, oh man, dadgummit, we got off track, guys. Supposed to be over there. That's another story unto itself. It's fun, actually. You know when this error happened? Like 1780. I mean, it's way a long time ago. So they discovered their error and they went back. But good news for us Tennesseans, we got just a little bit of amphibolite geology, which means, yay, we get to claim the Amphibolite Mountains ecoregion is part of Tennessee. But reality, it's only the western slope of one mountain. It's pretty cool. All right. Now, it's beautiful there. I mean, when I say this is a gorgeous area, it looks like Vermont, right? Just beautiful mountain ranges, very rugged, mountainside pastures with apple orchards. Just gorgeous landscape. But what do you notice lacking in this landscape scene compared to the picture that I showed earlier? No pines, right? So this should tell you something if you're flying over it, right? The soils are totally different. In this case, that ultramafic geology, that amphibolite, or it's actually mafic and ultramafic in this case. And just to reset your mind as to what that is, mafic means it's an igneous rock originally, right, of volcanic origin that has what in it? What makes it mafic? Mafic versus felsic. Dark minerals, that's right. Things like hornblende and amphibole and those kind of minerals, which you don't need to know, just know that it has a heavy concentration of dark minerals. Those dark minerals give it a high concentration of bases like magnesium. And because of that high degree of alkalinity, that means they're more on the basic end, or even, they're not really neutral. They're actually more type basic rocks. And so things that like acid-loving soils like blueberries and pine trees are not nearly as abundant in this landscape, okay? Now, here's another view, winter scene. Again, especially notice the general absence of those, not altogether completely missing. Some of those valleys definitely have some conifers, which like more acid soils. But take a look at that outcropping in the foreground, and that rock, which is a little bit weathered, looks kind of grayish or blackish. And if you were to bust that thing open, it has a distinctively blackish color pattern. Now, I'm going to send you around a piece of amphibolite, just so you can kind of put your eyes on that again and get that experience. Where's my rock out top? Yeah. All right, there we go. Yeah. Somebody stole, one of my grasslands in fact stole most of my I had a big chunk of amphibolites. They left me with just a little scrap. All right, that's what amphibolite looks like close up. It looks like it is salt and pepper colored, especially heavy though with the pepper, right? And so this is amphibolite bedrock. We have amphibolite in Alabama and in Virginia, in North Carolina, almost none in Tennessee except for the top of Snake Mountain. Now, there's some really cool habitats here. For example, out on the top of this long flat mountain here, there's a depression in the top of that mountain. If you were to fly over it in an airplane, you can see it. It's relatively flat up there. And all the water accumulates, forming this giant wetland, which is one of the largest of its kind in eastern North America. And it's a unique wetland type called a fen, F-E-N, fen. Say it with me. Fen, yeah. Here in the South, we call it, that's a pen. Or is it a pin or a pen? Well, this is a fen. And it's a type of wetland that is fed by groundwater seepage. There are endangered bog turtles in this fen, as well as a whole slew of other very rare species. This is the top of Snake Mountain that I was telling you about. The state line runs right up the nose of that ridge. All Tennessee gets of these rare exposures of amphibolite is literally about 50 feet wide at the most, because just downslope, it immediately goes into forest. And there are species that only grow on the outcrops. And so in all of Tennessee, that's the entire only place in the state is just that little bit of a spine right there.
What species?
Actually, the one I'm thinking about now doesn't even occur on the Tennessee side. It's just down the ridge on the North Carolina side. Hylotelephium telephioides, just barely over the state line. And some of these larger valleys between these mountains of this ecoregion have larger complexes of very rare wetlands called bogs, or again, fens is the most appropriate term. Long Hope Valley is one of these, and you can see that boggy meadow right there in the foreground. Okay, that's the Amphibolite Mountains. Got that one pretty clear? Cool. All right, any questions from online there?
Nope.
Awesome. Let's cover one more ecoregion, and then we'll take a break, okay? Next up, Southern Metasedimentary Mountain. So this is distinct from the Southern Igneous Mountains by the kind of geology. So instead of having granite and granitic gneiss, okay, in this case, we're going to have sedimentary rocks that have been heated up and molded and folded, right? So we're going to have metasandstone, which we could also call quartzite. Instead of shale, we're going to have phyllite or slate, okay? Instead of having limestone, we're going to have marble. There's a few other types. So the Metasedimentary Mountains region then is likewise is the area below the high mountain zone. This goes all the way from the bottom of the mountains to the high mountain's edge, which is 4,500 feet up. And importantly, whereas the igneous region is over here, right? The Metasedimentary Mountains region is to the west of that on the 66G, kind of over on this western side here. Most of Great Smoky Mountains National Park, almost all of it, in fact, except for the very tops of the mountains, is the Metasedimentary Mountains ecoregion. Okay, so again, those of you online, we're talking about this lighter green zone, 66G. Here is metasedimentary rock rather than igneous rock. Okay, so we've got places like Great Smoky Mountains National Park. You can see Cades Cove here. Here's a couple of the common rock types of this area. So this is the metamorphosed sandstone, quartzite, and in some cases we even have what's called metaconglomerate. The conglomerate remember, which is all those rocks with different particle sizes. It too has been heated up and remelted and sort of restructured, and you'll find that as well. If you've ever been to Hiwassee River State Park, okay, it's a very popular place to go rafting and kayaking. Most of the mountains at Hiwassee River are of the metasedimentary type. And if you've ever paddled the Ocoee River in southeast Tennessee, all those mountains around you are the metasedimentary rocks. So, for example, what you're looking at right there, that rock there, anybody, I know, again, we're just playing a geologist in the movies, but somebody try to identify that rock there based on, even a guess is fine. What do you think? I know that's hard, guys. I'm asking a lot because this is not a geology. It's not a geology class, Dr. Estes. Okay. Notice it's kind of that brownish color. Okay. It's probably a metamorphosed sandstone of some type. If you didn't know that, it's totally fine. Okay. We're going to work through this as a team. Okay. So, a lot of the Ocoee River Gorge has this type of rock in it, which is called phyllite. And this is a, let me step back. So of the metasedimentary mountains ecoregion, think back to the three basic rock types, right? What are most of the rocks here going to be of those three types? Are they sedimentary? Are they igneous, or are they metamorphic? No, in this region here, of the metasedimentary mountains ecoregion, are most of the rocks, which group do they mostly fall into?
Metamorphic.
Metamorphic, right? Good. Metamorphic. Laura, is that what you said?
Yes.
Awesome. So, in this case, something like phyllite, remember that we said metamorphic rocks kind of break into two groups. There's those that are foliated, which means layered, and the non-foliated. So, for example, a rock like some of those very dark sandstones doesn't have any evident layers. It's a non-foliated metamorphic rock. But notice those layers that you see in that rock on the left. That's a specimen of phyllite. Why does that matter? Well, imagine then if all these rock layers become upturned through mountain building, and some of those rocks now all of a sudden have layers in them. Okay. Think about as from an engineering perspective. What challenges do layered metamorphic rocks present that non-foliated metamorphic rocks do not present? Shear lines. Tell us about that, Chase. Exactly. The forces of gravity, all the weight of that rock on the mountainside, is going to cleave those rocks, resulting in shearing, right, or slippage. So if you have something like periodic, very low intensity earthquakes that are 2.5 on the Richter scale, or 3.0, or a 1.0, combine that with episodes of high intensity rainfall, right? We said this part of the world is 80 inches of rain or 75 inches of rain a year. Combine those two forces, a lot of rain and periodic light earthquake activity, you can expect major triggers of landslides. And that's exactly what happened here back in 2009, 2010. We're going to take a break, and when we come back, I'm going to show you a YouTube video clip of that mountainside just slipping away and falling away. And then I'll tell you a cool story around it. But before I let you go to break, so we have things like phyllite, which is the primary rock in the western end of the Ocoee River Gorge, and quartzite. Some people also, those of you who are rock nuts, might appreciate this. Some of the specific sandstone in the Ocoee Gorge is called meta-graywacke. That's a specific kind of rock. I don't care that you know that or not. We're gonna get back to it, guys. So before we go on, I want to tell one quick story about the geology of the Ocoee River Gorge and how that is connected to the ecology in a very fundamental way, and how it personally shaped my early career as a professor. One day I was, in my office over here and I got a phone call from a friend of mine, and he's my best friend from Chattanooga, one of my best friends, and he says, "Hey man, what are you doing?" He does not talk like me. He's not a redneck. He's like, hey guy, what are you doing over there? I was like, "Oh man, I'm just hanging out. What's going on?" "Ah, you're never gonna believe this. You're never gonna believe this. Hey, slow down, dude. What's up?" "What's up, man? Let me just tell you about this," right? So phone down, let's tell you the story. He gets a call from the U.S. Forest Service, and they said, "Hey, Dr. Shaw, we need you to come over to the Ecoregion Gorge." He's a professor at UT Chattanooga. They said, "We've had a landslide in the Ocoee River Gorge that has blocked off US Highway 64. That's the highway you see going along the north side of the river. This landslide has blocked off the entire highway. And all the mountainside is now like down on top of the road, all the way down, not in the river, but sort of right stop before going in the river." And Joey's like, "Wow, man, that's unfortunate." They said, "Yeah, in fact, this is going to cause delays for like almost a year. That's how long it's going to take to fix this." They said, "We can't simply move that rock because we don't know if the rock above it on the mountain is stable enough, right? If we move the rock below, it may trigger yet another landslide. Furthermore, there's so many jurisdictions involved here. The U.S. Forest Service owns the mountains, part of Cherokee National Forest. The Tennessee Department of Transportation owns the highway. The U.S. Army Corps of Engineers and the Tennessee Valley Authority manage the river. The Tennessee State Park System has jurisdiction over the riparian zone. And the U.S. Fish and Wildlife Service has jurisdiction because there's a federally endangered species right down on the riverbank. And so there are others, I'm sure, right? All these people are coming together. They said, "So we need you to come to the Ocoee Gorge Wednesday and join us because we need a botanist there to help listen to what's happening and make a decision," right? Can you imagine that? A botanist being asked to come to this party. So Joey shows up. "Hey guys, what's going on? Hey, hi. It's him."
It's a very good Joey Shaw impression.
It is kind of right. Completely bald head. Stands out, and he's standing around a group of 20, 30 guys, and gals that are all agency people, and they're studying and they're looking and they're writing and they're taking pictures. Finally, Joey, who's a very practical person, says, because they're all deliberating about what to do with the pile of rock. And Joey says to me, I'm not there. He says, "Well, it seems to me that before you move this rock anywhere, you got to know what's over there and over there, right? Because if you move this rock and you cover up an endangered plant that you don't know about, you're just hurting more nature, basically. You're causing more conservation problems. If you push it in the river, you're causing issues. If you move it down here, you're causing issues. If you're removing it and the entire mountainside gives way, what are we losing upslope?" Everybody's like, "Yeah, right, Dr. Shaw, it's a good point. Yeah. Well, what should we do about it?" Joey says, "Well, it seems to me that the first thing you need to do is a study. You need a study. We need to come out here and we need to know what's down here, up and down this river gorge." "Yeah, that's a great idea, Dr. Shaw. Hey, how about you get back to us next week with that, right?" And they said, "By the way, is this something you do yourself?" And he realized then he's over his head, right? He cannot survey the 15-mile long, extremely rugged Ocoee River Gorge by himself, even with his team of 4 graduate students. He says, "No, I'm going to call my friend and colleague at Austin P, Dr. Dwayne Estes." Right? So he calls me up. He calls me and we're starting to do, I'm like, "Oh my God, I can't believe it. I've been through the Ocoee Gorge a lot, man. I'm foaming at the mouth just the opportunity to go down there and study plants." At this point, this is 2010. I'm a professor I'm 30 years old, man. I got nothing but time, So I'm like, "Oh God, this is great." I have no experience writing grants. I got no experience bringing in money. So I'm looking to him, my older colleague who I did my PhD with at UT Knoxville, for guidance. He says, "Wonder how much money we could cost to do this work." I said, "I don't know. What do you think?" He says, oh, let's see here. It's gonna cost a couple students, it's gonna be some travel, you're coming over across the fee. Okay, we're gonna need to buy some gear, maybe a new pair of boots. I don't know. What do you think? Why don't you say a number and I'll say a number? We both said it out loud. $20,000. We almost stepped over each other, right? $20,000. Yeah, yeah. Hell boy, that sounds good. That sounds great. We came back and I said, well, let me run those numbers by our secretary here in the department. And I got to her and she said, 20,000, 75, 85, 126,000, 203, let's see, 392, 408,000. Joey and I about flipped, right? We're like, oh my God, there's no way we can go and ask these people for $408,000. So I go back to Joey and he said, you're out of your mind. You're out of your mind. They're not ever going to go for it. So we talked through it. We slept on it for 2 or 3 nights. We reassessed the numbers. We went back to Jean Langley, said, Jean, run the numbers again. She's like, there's no point. They're accurate. I promise you. You guys are misjudging this. You need to believe in these numbers. We believed her. We went into this meeting. We sit down, across the room, face to face. The guy says, hey guys, what's your estimate? Joey, who's the leader of the two of us, he says, 408,000. Great. When can you start? That was the beginning of a 4-year, amazingly ambitious love project that had so many students attached to it. We discovered 3 species completely new to science in the gorge, 2 of which ultimately one of which got named, the other 2 remain undescribed. But we got to know the geology of it. And some of those cool species that are there up on the side of these mountains are on these amazing phyllite outcrops, which is what brought us the project to begin with. The instability of phyllite led to the complete collapse of that road, of the mountainside onto that road, which led to us getting our first big contract and really helped to set the tone for our careers. Let me show you that video real quick. I think you guys get a lot out of this. Let's find it here. Hang on one second.
Did they clear the road?
They eventually did. By the way, the shutdown of that highway, it did take almost a year. But what made it doubly crippling is the fact that as soon as this collapse happened, another collapse happened on Interstate 40 between Knoxville and Asheville, North Carolina, and it shut the entire interstate down there. There's only 3 major passes through the Blue Ridge Mountains of Tennessee into North Carolina. Imagine then the economic disaster that caused for truckers and people just commuting. What was a 45-minute commute became a 3-hour through the mountains one-way drive. And so it was devastating. It had a devastating effect for a while on that region. All right, so let me go to YouTube here. And let's look up, let's call it Ocoee River Gorge landslide. There it is.
Today, that's a beautiful sunset on Middleton Weather Camp.
Also, that geologist, Wayne, saved all those people's lives.
Oh, exactly. Yes. So they were out there when they were filming, they were out there and they had a geologist on the side of the mountain who was checking the stability of the rock. They felt it begin to tremble and they're like, get down, get down. And the lady got off the mountain and they all moved back just in time before this massive collapse happened. So let's watch and listen. Any volume. Okay, we'll just watch it and see. There's that phyllite outcrop. See it layered? That's the original landslide. There they are running away. Yeah. Huh. Ain't that something? So if you still go through that gorge, you can see the big scar of that landslide. But imagine how many times through the course of geologic time those landslides have happened, right? That's what all they had to move right there. I don't know what they ended up doing. Actually, I have no idea where it ended up going. But we gave them an 800-page report 4 years later. And we walked almost every square inch of that northern side of the river gorge. I thought I would actually lose some weight through that process. Ended up not quite happening that way, but I was hoping to use that as a real opportunity to get fit. Okay, good. Now let's talk about another environmental disaster that happened just a few miles to the east, but a century or more earlier. Okay, let's go to the Broad Basins ecoregion. This is an ecoregion that's located in the low parts, the lower elevations of the mountain valleys of Southwest North Carolina and adjacent Southeast Tennessee, and a little bit of northeastern Georgia. Okay, this is an area that is currently identified here as area 66J, and there's several of these valleys, and particularly the one I'm going to emphasize here. If you've been to the city of Asheville, North Carolina, that's in the valley that's to the east over here, 66J. And then down in this portion here in the southwest is where I'm going to spend most of my time talking about this next example. This is what this area looks like. It's a big, wide open valley with small mountains and hills kind of in between. Unfortunately, a lot of these valley bottoms have been flooded through various lakes that have been created. This is called Chattooga Lake, which has impounded the Hiwassee River, the upper end of the Hiwassee River. And a lot of this area is very fire adapted. There's a lot of pines, a lot of sandy soil. But sadly, back in the 1800s, probably in about the 1830s or 40s maybe, copper had been, I don't want to say discovered by the white settlers that lived in that area, because it was accurately discovered by the Native Americans much earlier. But the white settlers began to seize and sort of take advantage of those copper formations. And of course, the Cherokees were completely eliminated. Well, not completely, because there's still the Eastern Band in parts of Western North Carolina, but many of the Cherokee of this particular region were forced west to Oklahoma. And so those copper deposits then were seized and taken by the new white settlers who were moving into this region. That copper, of course, is extremely valuable, right? And so they began to mine it. And in the original old days, that's how that highway actually that goes along the north side of the Ocoee River began. It actually was a Native American trail that had, for millennia. And then when copper was discovered, some of those early white settlers came in there and began to use dynamite and other means to widen that out into an actual horse trail and then into a wagon trail. And eventually, of course, it became US Highway 64. So the Ocoee Gorge is just west of this. And the headwaters area is part of this Broad Basins ecoregion. And the part that's in Tennessee is specifically known as the Copper Basin because of those copper deposits. But around the time of the Civil War, or just before the Civil War, these mines were at their heyday, and they were generating a lot of mining activity. And to get at that copper ore, they would have to smelt the rock and sort of burn it down and extract it. It was an extremely toxic process, very polluting to the environment. All that, you can see those pollutants right there being emitted out of this historical photograph. And because it's in a mountain valley, then those clouds of sulfuric acid, of sulfur dioxide, they were not able to rise and dissipate very effectively across the mountains. So instead, they sat in that mountain valley, hemmed in by the local mountains on all sides. And then when it rained, it fell as sulfuric acid. And the sulfuric acid destroyed everything. And so when I mean destroyed everything, I mean it looked like a moonscape. And the particular major time where this was most dramatic was in the early 1900s and into the sort of mid 1900s. And it was so severe that the Ocoee River, which looks beautiful today that you would raft, that's where the 1996 Summer Olympics were held. It's a dead river. It's very little biological diversity in the Ocoee because all that sulfuric acid and all that sedimentation drained into the Ocoee, went downstream and polluted that river so horrifically and caused so much acidification of the water. Even now, 120 years later, it has not recovered. We've lost a lot of the original fish species and crayfish and macroinvertebrate diversity that's there. And so you can see these old pictures here that are colorized images. Trains, of course, eventually came, and but just look at that. It looks like Mars. You know, it does not look like our region. Even those mountains in the far background were severely affected by that sulfuric acid smog. Now, this is the zone of destruction. This is a satellite image. You can see this from space. It's one of the features that's very visible. At about the time the Tennessee Valley Authority was established in the 1930s in response to President Roosevelt's New Deal, one of the big considerations was improving conservation measures, right? The CCC, the Civilian Conservation Corps. They were very concerned about planting trees and about preventing soil erosion. So the CCC came in, they planted a bunch of kudzu vines, if you know what kudzu is, right? In an attempt to stabilize these soils, and they planted a bunch of loblolly pine trees. Both species are not native to this region, and they, of course, had their own effect on this particular region. Now, fortunately, not all of the montane basins has been so deeply affected, but the Copper Basin of Tennessee has been dramatically impacted. Yes.
So that region, the rocks there are
Mhm.
naturally occurring copper deposits.
Yeah.
We also infer that there would maybe be deposits of other heavier metals or other toxic like matrix minerals that we've been talking about. Does that tell us anything else about the fauna?
That's a good question. I don't know the answer about that because it is in the Metasedimentary Mountains ecoregion, but I will say this, that underneath Copper Basin is a very unusual, like very small patch of igneous rock. And it actually comes up near the surface at one place in all that zone of degradation. And that's the only place in Southeast Tennessee where we get any type of igneous rock. Just north of there, in an adjacent county, there's a place called Sitico Creek. That's one of the more famous places in Tennessee for gold mining historically. So there are gold deposits as well. And gold mining was a thing in North Georgia and this part of Tennessee in the late 1800s. So that's another one of those very rare, elements that occurs in this area. Okay, let's go next to the Limestone Valleys and Coves ecoregion. This area is a very small, disjointed region, and it consists of these little bitty bits and pieces of isolated mountain valleys all up and down the sort of western side. And this is a really cool area. It's geologically part of the Ridgeon Valley, which is that brownish orange region to the left, meaning that it has the same kind of rocks. However, it's surrounded on all sides by the rocks of the Blue Ridge, so these metasedimentary rocks. So how did that happen? Well, remember those thrust faults we talked about, right? Where one rock type was thrust up and over the other. Well, then when that happened, these rocks began to erode away, and it eroded a natural hole through them. We call that a geologic window. And so it exposes these old rocks went up on top of younger rock. They eroded down, leaving an open space or a geologic window. So you're just like looking back through time. If you look down, this is that old rock. Here's the thrust fault. Here's the young rock. And you're looking down into what's called a geologic window now. So you're looking through old rock into younger rock. And here's that geologic window, and there's the fault. So when I say you can actually see the thrust fault, if you know what to look for, you absolutely can. It's very visible. Good point. It probably has to do with the fact that you have a mountain range on one side, a mountain range on the other. I'll show you what this kind of looks like in this view. So the mountains that you see on the right, this is Cades Cove in Great Smoky Mountains National Park. is all very erosion resistant meta sandstone, quartzite, okay? Same thing for the mountain range on the left. So to your question, Clayton, which is why did that stuff in the middle go away, right? It's very likely that as you had these folded rock formations that formed, in that fold was probably meta siltstone or marble or one of the shale types like slate, which are highly erosion prone. That all eroded out. Remember how we talked about it on lecture 1? Those easily erodible rocks washed away, leaving a valley. And what happened is it went all the way down to that younger rock layer that's below the thrust fault. Does that make sense? Okay. All right. So in this case then at Cades Cove, the valley floor is all dolomite, Paleozoic age. We would say actually Cambrian age dolomite. That's roughly 550 million year old rock with 1 billion year old meta sandstone on top of it. And then here you can see that. There's the phyllite, which makes the Ecoregion River Gorge so unstable. There's the Elkmont sandstone, which is metamorphosed. It's actually technically meta sandstone above it. This is Cambrian dolomite right there. Okay. Here's Cades Cove in outline, which there's a loop road. Anybody here been to Cades Cove, by the way? It's a beautiful place. It's absolutely gorgeous. Great place to see wildlife, black bears and white-tailed deer and all kinds of cool stuff. But in the eastern end of Cades Cove, there's a place called White Oak Sinks. It's a large sinkhole, and you can actually see the Great Smoky Mountains thrust fault right there behind the waterfall. That is the actual slipping point where the piece of 1 billion year old rock, which you would expect to be on the bottom, right? The older rock slid on top of younger rock. And that's the actual thrust fault right there. Okay, another really a great example of the limestone valleys ecoregion is called Shady Valley, Tennessee. This is way up in the northeastern part of the state. And this valley historically had an amazing complex of bogs, home to the endangered bog turtle. Sadly, most of these were, it also had some really great historic red spruce swamp forests. A lot of it was logged. Beavers were very common here back in the day. They would have kept a lot of these boglands open. And you can see some of these areas where these old creeks used to sort of flow and wiggle and twist. And then the good old Army Corps of Engineers came in here in the 1940s and dug this out and made a canal out of it to drain it. And then what happened? The local farmers said, man, that's great for farming. You know, those newly drained boglands, rich histosols in some cases, those organic soils, perfect for growing agricultural crops when you dry them out, especially watermelons. Apparently, this is a big watermelon area right here in this valley. But thankfully, the Nature Conservancy has bought parts of this valley floor and have begun to restore. And this is the this is called the what is this called? Orchard Springs Preserve. This area here, and they've begun to restore the streams, hydrology. They're protecting the bog turtle. They're trying to make sure that this is properly managed. And there's another area that's right down here called Schoolyard Springs, both of which are the only 2 protected remnants in the floor of this valley. Any questions about that before we move on to the next one? Okay, I think this might be our last ecoregion for the Blue Ridge. And this is called the Southern Sedimentary Mountains. Now, what's the distinction between this and metasedimentary? What do you think? Yeah, these have not been metamorphosed. These are just regular sedimentary rocks that are uplifted as part of the mountain, but they're on the westernmost edge of the Blue Ridge Mountains, farthest away from the impact with Africa and with Europe, as you'll come to understand in a couple weeks. And because of that, they've been buffered against and protected against the forces of metamorphism. And so they still are regular sandstone rocks and limestone rocks and siltstone and so forth. And so these form just a very thin western edge. You see it right here, these light colored mountains. right up here on the very edge. Now, as you get up into Northeast Tennessee, around East Tennessee State University, most of the mountains at that point are the sedimentary ranges. And this continues on up into Virginia. It's at westernmost edge, okay? Now, if you're looking at this from Knoxville, here's downtown Knoxville. You can see the World's Fair Park with this globe shape here. It's quite easy to see these, at least three of ecoregions are kind of displayed easily. The first is the sedimentary mountains. Everything in front of that, here back, is the ridge and valley ecoregion, which we're about to get into next, okay? But when you reach the edge of this, what makes you in that Blue Ridge region? You've passed the contact zone between the Great Smoky Mountain thrust fault. You've literally stepped over that line, right? And on this side of it is the sedimentary mountains ecoregion. And so that's a sandstone mountain. The very next mountain behind it, so Gatlinburg sits back in here at the very base. Pigeon Forge would be like right in here, for example. But the very next mountain range, these taller ones, are the metasedimentary mountains. But notice the very top of those, above 4,500 feet, that's metasedimentary. The very top of the highest mountains in the background is what we call the high mountains ecoregion. Finally, you can't see it from here, but in the backside of these mountains, in the valleys between, are those geologic windows. I want you to make sure you remember that we call the limestone valleys and coves. If you've been to the Smokies, there's a couple towns that are in those, like the little town of Townsend, Tennessee, and Walland, Tennessee, are both in the limestone valleys and coves ecoregion. Here's a few photos. Here's Star Mountain, which is just looking down on the Hiwassee River State Park. And this is part of the sedimentary mountains that's right there at the entrance. A hugely important area historically for the Cherokee. But that's sandstone geology that has not been metamorphosed there. Farther north up in Tennessee, the Nolichucky River. Again, these are sedimentary rock layers. By the way, Spanish explorer Hernando de Soto came down this river in 1540. He was the first white person to enter the Appalachian Mountains. He was a Spanish conquistador who unfortunately spread disease and hugely detrimental diseases to the Native American populations of this region for the first time ever. It was their very first contact with white settlers, with white explorers. A very important rock that has Native American pictographs on it is called Paint Rock. This is located near Hot Springs, North Carolina. It has centuries old Native American pictographs where they've painted on the rocks here. And those are all sedimentary rocks of sandstones and shales and other kinds of sedimentary rocks. Black Rock Cliffs up in Greene County, you can see is sandstone there. And with that, we have finished the Blue Ridge. Those are the different